Welcome, everyone, to the deep dive. Today, we are going to talk about AI agents and specifically the kind of vibe coders need to actually build them effectively.
Yeah, that's a great way to put it.
We're not just looking at what they are, but, how you can actually build them and finding the approach that really fits your style, your coding VOD.
Exactly. And we've pulled together some really interesting material for this. We've got stuff from Microsoft's foundational lessons, some practical guides from places like IBM and AEN,
Okay.
and even a Reddit thread, where
Yeah.
people are asking exactly that. How do I even start with this stuff?
Yeah, right.
So our mission today is really to um, distill those core ideas, look at the different ways you can get your hands dirty building agents, and sort of highlight what makes them powerful but also practical.
Okay, sounds good. So whether you're like a seasoned pro, just starting out, maybe somewhere in between, we'll try and guide you through the essentials, the patterns, the tools, maybe help you find your next go-to for automation.
Let's do it.
All right, let's unpack this then. First things first. What exactly is an AI agent?
Well, at its heart, an AI agent is basically a system, a program designed to perform tasks autonomously.
Autonomously, so on its own.
Yeah, think of it like a digital helper acting on your behalf or maybe on behalf of another system. Sources like IBM and N8N, they both point to this core loop.
A loop.
Right. They perceive their environment, they gather information,
Mm.
they make decisions based on that info and their goals, and then they take action.
Perceive, decide, act.
And they can range, from fairly simple chatbots doing one specific thing to really complex systems interacting with lots of different services.
Got it. So they're active, sensing, and doing things. What are the fundamental building blocks then? What makes them tick?
Okay, so there are basically four key components you'll find in pretty much any agent. First up is perception. Yeah, this is how the agent gets information, how it sees its world, so to speak.
Mm-hmm.
It could be reading text commands, monitoring system events, pulling data from websites, APIs, documents, you name it.
So like it's input layer, it's digital eyes and ears.
Precisely.
Ah,
Exactly. Then comes decision making. This is the agent's brain.
the smart part.
Right. It takes all that perceived information, looks at its internal goals or instructions, and figures out, what's the next step.
Okay.
Often, a large language model, an LLM, is the core reasoning engine here. It can understand complex stuff, make plans, but you might also see rule-based logic or other machine learning models involved too.
And planning is important here.
Absolutely, especially for bigger goals. Breaking down a complex task into smaller, manageable subtasks is really key for the decision-making part.
So it understands the destination and kind of plots the route to get there.
You got it, which leads us straight to the third piece, action.
Doing stuff.
Yeah, based on the decision, the agent has to actually do something,
Mm.
interact with its environment. This could be sending a message, calling an external API, running a database query, triggering some other workflow.
Uh-huh.
The ability to use different tools is fundamental here. That's how it actually affects things.
Okay, so perception, decision, action. That sounds like a cycle, doesn't it? You perceive, decide, act, and maybe that action changes what you perceive next. Starts all over again.
That's exactly it. That loop is fundamental. But there's a fourth critical piece, and this is what really separates agents from, say, simpler scripts. It's memory.
Memory, okay.
Agents need to remember things. Past interactions, information they've learned, data they've seen. It gives them context, allows for personalization, helps them improve.
Right.
And this memory can be short-term, like remembering the current conversation, or long-term, like storing user preferences, building up knowledge over time, maybe using external knowledge bases through techniques like retrieval augmented generation.
It makes me think of something simple like brushing your teeth. You perceive it's morning or bedtime. Perception. You decide to do it. Decision. The action is the brushing itself, using tools like a brush and toothpaste. And you have memory, hopefully, of whether you already did it.
Exactly. That's a perfect analogy. And for AI agents, that memory allows them to adapt, to seem stateful, to learn. Like IBM points out, that's a huge difference from basic systems that just handle one request and forget everything immediately.
Okay, so we've got the core parts. Perceive, decide, act, remember. How does this loop actually work in practice, especially with LLMs driving a lot of this now?
Right, the LLM is usually central to that decision-making piece. It's great at understanding natural language, figuring out intent, making a plan.
But it doesn't know everything, right? Its knowledge is kind of frozen in time.
Precisely. Its training data is static, and it doesn't know about real-time events. That's where tool calling becomes absolutely essential. Yeah, the agent needs to use external tools.
Mm.
Think APIs, functions, databases, web scrapers. sometimes even other specialized agents. These tools let it get up-to-the-minute info or perform actions beyond just generating text. It bridges the gap to the real, live world.
It's like giving the agent permission to use specific software or browse the web, basically.
Exactly. Now, for simple things, the LLM might figure it out directly, but for complex goals, planning is often needed. This involves task decomposition, breaking that big goal down into a sequence of smaller steps.
Okay.
And then the agent performs what we call agentic reasoning. This means it can kind of reflect on its progress. It looks at the results from its tools, maybe notices an error, reassesses its plan, and self-corrects as it goes.
So it can learn from mistakes mid-task.
Yes, or learn from successes, or even feedback from a human or another agent. It uses this reflection to improve its planning and execution over time.
I think I saw mention of different strategies for this loop, things like React and ReWO.
Ah, yes. Those are specific ways to structure that agent loop. React stands for reasoning and acting. It's basically a cycle. Think, act, observe. The agent reasons, takes an action, like calling a tool, observes the result, then reasons again based on that new observation.
Okay, step by step.
Right. ReW, on the other hand, stands for reasoning with occupied observations. It's a bit different. The agent tries to create a more detailed plan up front, predicting the steps and the tools needed before it starts executing.
So plan first, then act.
Kind of, yeah. The choice often depends on the task. React is good when things are unpredictable, you need to explore. ReW might be more efficient if the task structure is clearer from the start.
This is fascinating, but it definitely raises the big question. Knowing the parts and how they spin is one thing. How do you actually, build these things? Because that seems to be where your personal style, that vibe we mentioned, really comes in. The sources seem to highlight a few different ways people are tackling this.
Absolutely. And that Reddit thread we found, it's full of developers asking exactly this. Should I build it all myself? Use a library, go low code. It really shows people are looking for the path that fits them.
Okay, so let's break down those vibes. What's the first one? Maybe for someone who really loves digging into the code.
Right, that would be Vibe 1, the hardcore coder. This is the pass where you're essentially building the core agent components, the perception, decision, action, memory loop, pretty much from scratch.
Wow.
Yeah, you're writing the code yourself, probably using something like Python, pulling in various ML libraries, maybe connecting directly to LLM APIs, handling all the logic for tool use and memory management yourself.
That sounds like a lot of work. Intense.
It is. As the NANet article points out, the huge advantage is maximum flexibility.
Yeah.
Total control. You can fine-tune every little piece, optimize it exactly for your specific, unique needs.
But the downside?
The downside is it demands serious technical expertise, a significant amount of time, and just plain effort. You often see this approach for cutting-edge research projects or maybe highly specialized production systems where nothing off the shelf quite fits. This vibe is definitely for you if you love being deep in the weeds, controlling every layer.
Okay. Total control, high effort.
Good.
Got it. What's the middle ground then?
That brings us to Vibe 2, the framework fan. And honestly, this is probably the most common starting point for developers right now.
Okay.
Here, you're leveraging existing frameworks, open source or commercial, that are specifically designed for building agents. Think LangChain, Llama Index. Microsoft has Semantic Kernel and Autogen. Hugging Face has small agents. These names pop up a lot, including in that Reddit thread.
So these frameworks, they handle some of the grunt work, the boilerplate.
Exactly. They provide pre-built components and abstractions, standard ways to connect to different LLMs, manage memory, define tools, structure prompts, parse outputs, orchestrate the whole agent workflow. It massively speeds up development compared to starting from zero.
Right. You're not reinventing the wheel for basic agent mechanics.
Precisely. You get building blocks for common problems.
What kind of skills do you need for this approach? Still heavy coding.
You definitely still need to be comfortable coding. You need to understand the framework's architecture, its concepts, how its pieces fit together. It's less about building everything from scratch and more about using the provided code and structure effectively than customizing where needed.
Okay.
The Microsoft source, for instance, positions their two main frameworks differently. Semantic Kernel is more focused on building robust, enterprise-ready agents. It supports C#, Java, Python, and really emphasizes the developer experience for production systems.
Right.
Autogen, on the other hand, came out of Microsoft Research. It's really strong for experimenting with multi-agent systems, where multiple agents collaborate. It's great for trying out newer, more complex agent interaction patterns. They generally suggest starting small, maybe with one agent in either framework, before diving into multi-agent setups.
So this vibe feels like a good balance. You get structure, you get speed, but you still have plenty of room to code and customize.
Exactly. It's a very popular approach for a reason.
All right, that makes sense. Use the tools to build faster. What about the third option? Maybe for folks who aren't deep coders or prefer a more visual approach.
Yep, that's Vibe 3, the visual builder. This involves using workflow automation platforms, particularly those with strong AI integrations. A key example mentioned is N8N.
Innate them.
These tools provide a visual node-based environment. You literally drag and drop nodes representing different services, an LLM call, an API request, a database query, some logic, and connect them with lines to define the agent's workflow.
So you're basically drawing the agent's process flow.
Pretty much. It significantly lowers the barrier to entry. You can build quite sophisticated agents and automations much faster, sometimes with very little traditional code. The focus shifts from writing lines of code to designing the process logic and connecting the right services.
Interesting. So it's less about coding syntax and more about workflow design.
Exactly. It's great for rapid prototyping, automating business processes, and integrating different services together visually. If you think visually and love connecting the dots, literally, this might be your vibe.
The NA1N example in the source material, the research agent one, seemed like a good illustration of this.
It really was. It kicked off with a simple trigger, a chat message containing a URL.
Okay.
The core was this AI agent node. That node acts as the orchestrator, the decision maker. You give it instructions in a system message telling it its goal. Scrape the web page at the URL, summarize it, save the summary to Notion, and then notify someone on Discord.
And crucially, you tell it how to use the tools you provide.
Yes, that's key. The instructions explicitly said something like, always use the website scraper tool to get the content.
And the tools themselves were just other nodes in the visual workflow diagram.
Exactly. They set up a standard HTTP request node to call a web scraping service, like Browserless, and configured it as a tool for the agent, defining placeholders like URL for the agent to fill in. Then, a Notion tool node was added to save the data, mapping the outputs the agent would generate, like title, summary, to the right Notion database fields. And finally, a Discord tool node to send the notification, where the agent could even craft the message content dynamically.
So the agent node gets the URL, follows instructions, decides use scraper tool, gets the text back, decides use LLM to summarize, decides use Notion tool to save, decides use Discord tool to notify, all visually wired up.
Precisely. It's a powerful way to build intelligent automation without needing deep coding skills for every step. And seeing people on Reddit asking about code versus no-code options just confirms that these different vibes, these different approaches, are all relevant depending on the person in the project.
Okay, that gives a great overview of the different ways to actually build these things. Once you've kind of picked your vibe, how do you go about designing agents that are truly smart, reliable, able to handle complex stuff effectively? Are there specific design patterns we should know about?
Yeah, absolutely. Beyond the basic loop, there are definitely patterns for building more intelligent and robust behaviors. The Microsoft material actually highlights 3 core design principles first.
Principles, okay.
Space, time, and core. Space is about the agent's environment, how it connects to events, data, people. It emphasizes making the agent discoverable, giving it clear instructions, good UI UX, because even a brilliant agent is useless if people can't figure out how to use it or what it does.
Right, the context it operates in matters.
Definitely. Time is about how agents operate and improve over time. Connecting them to past events using patterns like reflection, which we'll touch on more, allows them to learn. Showing users the agent's history builds transparency too. It makes them feel less like static tools and more like evolving partners.
So they get better with experience.
That's the goal. And core is about embracing uncertainty. LLMs aren't perfectly predictable, so building trust is key. This means visible controls like a pause button, an on-off switch, giving users transparency and the ability to intervene. You manage the unpredictability by giving the user some control and visibility.
Makes sense. Control what you can, be transparent about the rest. What about more specific patterns for how they work?
The tool use design pattern is absolutely fundamental. We talked about tool calling, but this pattern goes deeper. It's about how the LLM reliably interprets natural language and picks the right tool with the right inputs. The semantic kernel example was good here. The user says something like, find destinations not in Europe. The agent needs to understand that constraint and apply it correctly when using the getAvailability tool. The pattern also covers how you define tool behavior, like should the agent always use this tool if asked, or can it choose? And critically, handling tool failures, maybe trying a backup.
Right, backups are important. And you mentioned agentic OG before. How is that different from regular OG?
Yeah, good question. Agentic argy is more sophisticated. Basic argy fetches relevant documents and gives them to the LLM as context. Agentic argy adds more agent-like steps: planning, tool use, and verification.
How so?
For a complex question, the agent might first use tools to clarify the request or get correct context. Then it uses argy to find relevant info. Then it uses its reasoning ability to check if the retrieved info actually answers the question fully and accurately. It might decide it needs more info, refine its query, or even use another tool based on what it found. The travel examples illustrated this well. Simple RA for static insurance info. RAG plus a weather tool call for current temperature. And then agentic logic to first find potential cold destinations using RA, then use the weather tool specifically for those candidate cities. What's really powerful is the agent can remember how it found information previously and potentially get better at it over time.
So it learns how to search its knowledge and use its tools more effectively. That's a really key insight.
It really is. Then there's the planning pattern. This is crucial for complex goals, especially when you have multiple agents. It's about breaking the goal into structured subtasks.
Like a project plan?
Sort of, yeah. The example used Pydantic, that's a Python library, often used to define and validate data structures. The agent could generate a validated JSON plan for a trip, outlining steps like book flights, find hotels, plan activities, maybe even assigning these subtasks to different specialized agents within the plan. The LLM is smart enough to understand natural language constraints like family-friendly and bake those into the structured plan.
Speaking of multiple agents, you mentioned a multi-agent pattern.
Yes, this is when you have several agents working together. There are different ways they can collaborate. You might have a group chat model where a manager agent routes tasks to specialist agents, or a handoff model like an assembly line where agents perform sequential steps, or collaborative filtering where different agents offer perspectives that are then combined or reviewed.
Okay.
The source had a nice reviewer checker example. Imagine a front desk agent suggesting tourist activities and a concierge agent reviewing those suggestions based on a specific goal, like finding non-touristy options in Paris. The concierge agent approves or rejects the suggestions, guiding the front desk agent. It shows how agents can refine each other's work to get a better outcome.
That's a really powerful concept. Agents collaborating, even critiquing each other. And how do they get smarter individually over time? That reflection thing.
Exactly. That brings us back to metacognition. Basically, agents thinking about their thinking. They can analyze their own performance on past tasks, identify where they made errors or what worked well, and use that insight to improve their future planning, tool use, or responses. The reflection pattern is how this is often implemented.
Can you give an example?
The flight booking example was good. An agent helps book a flight. Maybe the user provides feedback like, "No, I prefer later flights." The agent, using the reflection pattern, stores this preference. The next time the user asks for flights, the agent retrieves that preference from its memory and proactively suggests later options first.
Wow. So it actually learns user preferences and applies them later.
Yes, when designed well. It requires storing and retrieving that feedback or learned preference effectively, using its memory component.
Okay, this is getting incredibly sophisticated. But with all this power and complexity comes risk, right? How do you make sure these agents are, trustworthy, reliable, and actually ready for prime time, ready for the real world?
That's a huge area, getting agents production ready. It involves tackling the unique challenges of deploying systems that are partly driven by unpredictable LLMs and can take autonomous actions. One really crucial practice is establishing a solid system message framework.
More than just writing a good prompt.
Yeah, much more. It's about having a scalable, repeatable process for creating those core instructions for your agent. Using templates, refining them iteratively, maybe even using another LLM to help generate detailed, robust system messages based on high-level descriptions of the agent's role and responsibilities. It ensures consistency and clarity in the agent's core directive.
Using AI to help write the AI's instructions. That's clever.
It can be very effective. Another absolutely essential practice, especially when agents can take actions with significant consequences, is building in human-in-the-loop, or HITL.
Human oversight.
Right. Designing specific points in the agent's workflow where it must pause and get approval from a human before proceeding. Think sending out a mass email. executing a financial trade, making a critical configuration change. IBM really stresses this for responsible deployment. Agents can be autonomous, but humans need control points for high-stakes actions.
Okay, so HITL for critical tasks. What other best practices help with reliability and control?
The IBM source lists several good ones. Activity logs are vital. Keeping a detailed trace of the agent's perceptions, decisions, tool calls, and actions provides transparency. It's invaluable for debugging, understanding behavior, and building user trust.
Seeing why it did something.
Exactly. Interruption capability is also key, a way for a human to cleanly stop an agent if it gets stuck in a loop or starts doing something unexpected. Unique agent identifiers are important for traceability, especially if you have many agents or they interact with external systems. And ongoing human supervision, particularly during development and early deployment, is crucial for monitoring, catching failures, and guiding the agent's learning.
And when it comes to actually deploying them and keeping them running smoothly, evaluation sounds like a big deal.
It's absolutely critical. And the sources emphasize evaluating the entire system, not just the final output. You need to evaluate at every step of the agent's process.
Every step.
Look, evaluate the quality of the LLM's initial response to the prompt. Evaluate whether the agent correctly identified the user's intent. Evaluate if it selected the right tool. Evaluate the output of the tool itself. Evaluate the agent's final response, and capture user feedback. Evaluating meticulously at each stage helps you pinpoint exactly where problems are occurring in that complex chain reaction. It also helps you understand the downstream effects if you change one part, like swapping the LLM or updating a tool.
Right, a small change could have unexpected consequences later in the process. And you mentioned error handling before with the tool use.
Yes, robust error handling is non-negotiable for production. The YouTube example showed this. Well, the primary get flight times tool failed with an error. But because a backup tool, get flight times backup, was defined, the agent could recognize the failure and successfully use the backup instead, completing the task, planning for things like API downtime, network issues, unexpected data formats. It's essential for real-world reliability.
And probably managing costs, too. I imagine these things aren't always cheap to run.
Definitely. Cost management, as IBM notes, is another practical consideration for making agents viable in production.
Wow. Okay, we have covered a ton of ground today. We went from the basic parts of an AI agent: perceive, decide, act, remember, through how that loop operates with LLMs and tools. Then we dove into the whole vibe check, the different ways you can actually approach building them, whether it's coding from scratch, using frameworks, or visual tools.
Right, finding your style.
Yeah. And then we got into these really sophisticated design patterns like agentic Raj, multi-agent systems, metacognition, and finally, how to make them trustworthy and actually ready for deployment.
Indeed. I think the key takeaway is that building effective AI agents isn't just about plugging in an LLM. It's a real design discipline involving careful thought about perception, planning, how they use tools, how they remember, and how they interact safely with systems, data, and humans.
And there's a path for every kind of builder, every vibe.
Absolutely. Whether you thrive on deep code control, prefer the speed and structure of frameworks, or love the visual approach of workflow automation, there's a way in.
So, thinking about all this, what does it mean for you listening as these agents get smarter, more capable, potentially collaborating, learning?
It really poses an interesting question, doesn't it? Given these different building approaches, these different vibes we talked about, how might you leverage them? How would you choose to build an agent that doesn't just automate something simple, but becomes a genuinely intelligent, adaptive partner for whatever you're trying to achieve?
Yeah, finding that right combination of tools, patterns, and your own building style seems key.
It's definitely a journey of learning and experimenting.
Well, we hope this deep dive gave you some valuable insights and maybe sparked some ideas about which AI agent building vibe feels right for you. Thanks for tuning in.